SuperEarth 55 Cancri orbits in front of its parent star in this artist's illustration. Credit ESAHubble. Kornmesser 55 Cancri is a SuperEarth, about twice our planet's size, that zooms around its star in 18 days. It has a surface temperature of nearly 4,900 degrees Fahrenheit, 2,700 degrees Celsius. For a while it was dubbed the Diamond Planet because scientists suggested that it was composed of diamonds and graphite. While that theory is not as popular today, the planet still remains an interesting object of study due to its high density and its very close proximity to its parent star. Several follow-up studies have yielded more insights about its surface, as well as its atmosphere. Astronomers discovered the planet in 2004 after looking at the spectrum of its parent star, 55 Cancri, one of two stars in a binary system about 40 light-years from Earth in the constellation Cancer. There are at least 4 other planets in the same system, mostly discovered before 55 Cancri. The team led by the University of Texas at Austin's Barbara MacArthur discovered subtle tugs on the parent star that could be explained by the presence of yet another planet. While the planet's existence was challenged by a second research team in 2005, a separate team in 2006 confirmed it. Astronomers initially thought 55 Cancri, abbreviated 55 CNCE, had an orbital period of 2.8 days, but measurements in 2011 showed that the planet is much closer to its parent star. Observations with Canada's most microvariability oscillations of stars space telescope demonstrated an orbital period of less than 18 hours. Researchers estimated the surface temperature of 55 Cancri could be as high as 4,892 F 2,700 C. Follow-up observations with the Spitzer Space Telescope in 2012 showed that 55 Cancri is much weirder than anticipated. While original estimates said the planet was dense and rocky, Spitzer suggested the planet includes a healthy proportion of light elements and compounds such as water. However, the planet's high surface temperatures contribute to a supercritical fluid state, the researchers said, meaning that the gases are in a liquid-like state. A model of the planet's interior in 2012 suggested that 55 Cancri is made up of carbon principally as diamonds and graphite, as well as iron, silicon carbide and possible silicates. Lead researcher Niku Madhusudan, of Yale University, said that their model was different from previous ones because unlike previous teams, they did not base their assumptions upon Earth's chemical composition. However, this idea was challenged in 2013 by University of Arizona astronomy graduate student Johanna Tesk. In a statement at the time, she said the parent star of 55 Cancri is both cooler than the Sun and has more metals. She also said the 2012 study did not properly analyze the single oxygen line in the star's spectrum, leading to possible errors. Her research instead found that the host star of 55 Cancri has 25% more oxygen than carbon. In theory, 55 Cancri could still have a high carbon-to-oxygen ratio and be a diamond planet, but the host star does not have such a high ratio, Tesk said in the statement. So in terms of the two building blocks of information used for the initial Diamond Planet proposal, the measurements of the exoplanet and the measurements of the star no longer verify that. Ongoing studies of the planet are trying to figure out more about its weird nature, though. Researchers observed the planet using the Hubble Space Telescope and Spitzer Space Telescope, with results published between 2013 and 2016. Some of the theories put forward about its surface include volcanoes or runny lava, which would help explain the wide temperature swings between day and night. Meanwhile, analysis of its atmosphere suggests the planet's envelope is mostly made up of hydrogen and helium, more gas giant-like than Earth-like. Video SuperEarth exoplanet's atmosphere characterized for first time. Additional resources. NASA Earth and SuperEarth. CNews astronomers create thermal map of SuperEarth 55 Cancri.